There's the new bolt cut off to 1 inch in length to match the original right there. Cleaned up the end of the bolt where it was cut off on the grinder. Used a nut, spun a nut on to make sure the threads are clean. Then I did do a test fit in the tractor steering box to make sure it went okay, and it did. Now what we'll do is slip this aluminum sleeve over just to distribute the force of the jaws to allow the true centering of this bolt to the middle of the spindle of the lathe. There's a couple ways you can go about holding it. You don't have to, I suppose, use anything. You could clamp it directly like this, though you do run the risk of it not being exactly centered. You could use a piece of copper tubing pipe here. This is a little bit too big for this application, you can see that. I could take a piece or section out of this and then, shrink it up. But I keep aluminum strips around anyway, like you see here. This is one that I actually got a bunch of these I use for shimming of the jaws when I have different projects I'm working on. But I took one of these and just bent it around the bolt, like you can see there, and we'll clamp it up. Once I've got the bolt clamped in the 3-jaw chuck, I will spot drill it with the center drill right here just to make sure I get a clean starter hole. Then I will drill all the way through I haven't decided what size drill yet. I got to figure out what the size of that zerk fitting is, the opening of that zerk fitting, and I'll drill all the way through first. Then I will come back with the appropriate tap drill size, number 3 right here. This is a new bit. I've never used it before. And drill about 1/4 of an inch deep, whatever the distance of the threads on that zerk is. I think it's 1/4 inch plus for the tap drill size, and then we'll tap it. I think we've got everything all set up. I have a small center drill right here. I'm going to spot drill the middle of that bolt. Obviously the bolt is clamped securely in the chuck. I'll put a little lubricant on the spotting drill here, the center drill in a second, and then we'll just start the process. I am going to then switch to a 1/8 inch drill bit to drill all the way through before I switch to the number 3 to drill the clearance drill or hole for the 1/4 by 28 zerk fitting. You will notice I took all my jewelry off, rolled my sleeves up. You need to be really careful when you're working around this kind of equipment because a sleeve could get snagged really quick in the spinning chuck, and the outcome would not be pleasant at all. You could get hurt really bad really quickly. So I'm very careful when I'm using this kind of equipment. So let's go ahead and get started. I've switched over to this is a brand new 1/8 inch drill bit. This will be for the through hole. It goes all the way through the bolt. This is a very good quality drill. It's an American made drill. I only buy American made drills, and they're not that much more expensive than inexpensive imports, and I get much more life out of them, and they cut much better. All the way through I could feel when it went through and it finally cleared. So now I'm going to switch to the number 3, and I'm going to drill about a 1/4 inch plus deep hole, which is the clearance hole size for the tap. Number 3 clearance drill for that Zerk fitting. I measured the depth of the threads on that Zerk, and it's a 1/4 inch or just under a 1/4 inch. So I'm going to drill the hole, the clearance hole, just over a 1/4 inch. I'm going to use the graduations here on the tailstock, and those are marked off in 1/8 inch increments, so I can use this as a visual guide as to how deep to go. It's not real critical as long as I go deep enough to accommodate the depth of the threads on the Zerk. I'll be fine. I'll go a little bit deeper than that just to make sure. So now I'll verify the depth of the clearance hole I just drilled with my caliper just to make sure I'm deep enough, and if I am, I'll go ahead and switch over to the tap and we'll tap those threads. So we're well over a 1/4 inch. Setup's complete. Taper tap in the tap wrench, which is centered on this live center in the tailstock. I'll use the hand wheel of the tailstock to turn or push the tap into the hole. I already have lubricated the threads. I have the back gears engaged on the lathe to prevent the chuck from turning, and eventually I will probably switch over to this bottoming tap as I get towards the bottom of the hole, though that's probably not technically necessary. Right there's the bottom of the hole, and that should be plenty deep for the Zerk. So let's get the Zerk and we'll do a quick test fit. So there's our finished replacement bolt with the Zerk centered in the bolt. You can see on this side it came out reasonably centered here, which is what we wanted. There's a little burr right there, so I'll take it over the bench and touch it up with a file. Remove the Zerk, flush it out with brake cleaner, make sure it's clean of any chips or debris, and then we'll go ahead and install it in the right hand side of the steering box. I added an oil washer to the bolt. Now we're just going to go ahead and put it in. Now all we need to do is pump this cavity full of that grease we talked about earlier. That's going to take a while. I got 2 full tubes of grease. Not sure exactly where that's going to come out in terms of the filling of the cavity, but I'm going to start with 2 tubes. If I don't think it's adequate, I can always add a 3rd. I'm not going to show all that on video because it's probably going to take some time, of course. I thought folks might be interested in seeing how thick this grease is. Maybe that gives you a sense of the consistency. Right there. Quite thin, actually. I'm going to use the air-powered grease gun just because of the ease of not having to pump that cavity full of grease by hand. And you can see here I did purge the grease gun of the old grease, the red grease, and you can see the new grease coming through right here. So we're about ready to go. So my discovery or learning is that this is not a vented cavity. So as I attempted to, or started to pump grease in through this fitting I made, it didn't take long for me to discover that something was wrong. And then it dawned on me that it wasn't vented, air vented, and the grease had, or the air rather, had nowhere to go. So I pulled this out and I could tell right away that grease wanted to start to ooze out. And I did catch it, I did capture it, so I didn't waste it. But a ribbon about, that long or so ended up just oozing out. And I could hear some popping in there as the air was escaping. So, what am I going to do now? Because there's no means to vent this tube, or this cavity, given the design, this design of the column. So I came up with this. I removed the Zerk fitting from the end of the hose. This is, of course, the grease gun. I removed the Zerk fitting from the end of the hose, rigged up this little series of tubes, flexible tubes. This black hose is a little bit smaller than the threaded hole here. So when I inserted that all the way to the back, I kept it to the bottom of the threaded hole, and that will allow the air to escape, and I moved it around a little bit and I could hear it popping. And I got a whole tube of grease in that way. So this tube right here is empty. For all practical purposes, it's empty. So the grease, when I pretty much finished this tube, the grease started to ooze back out again. So that told me the cavity apparently is full, so I'm going to stop. I'm not going to attempt to put the second tube of grease in at this time. I think what I'll do is I'll put the original bolt, where is it? The original bolt right here back in. Consider this kind of a wasted effort. I didn't really need to use it, as it turned out. But so be it. You know, that's how you live and learn on these kind of projects, having never done this before. I will use the tractor initially this season, start of the season, and eventually I'll pull the bolt back out, check the grease. If I don't see grease or I think it needs more, I do have that second tube that I can pump this cavity full. So I know it's got lubrication in here right now, which is certainly better than what it was. And I should have accounted for the air locking or lack of venting in this, just something that didn't occur to me until I got started with the project. So that's where we're going to end up with this video today, folks. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.